Properties of electromagnetic radiation. Electromagnetic radiation is a form of energy that travels through space in the form of waves. It consists of oscillating electric and magnetic fields that are perpendicular to each other and travel at the speed of light. Here are some of the properties of electromagnetic radiation. Wavelength. This is the distance between two consecutive points in a wave that are in phase with each other. This is commonly measured in nanometers or micrometers. Frequency, this is the number of cycles of the wave that pass through a given point in 1 second. It is usually measured in hertz. Amplitude, this is the height of the wave and represents the intensity or strength of the radiation. Then velocity, electromagnetic radiation travels at the speed of light, which is approximately 299,792,458 meters per second. Polarization. This refers to the orientation of the electric and magnetic fields in the wave. Electromagnetic radiation can be polarized in different directions. Next is the energy. The energy of electromagnetic radiation is directly proportional to its frequency. This means that high frequency radiation has more energy than low frequency radiation. Spectrum. Electromagnetic radiation can be divided into different regions of the spectrum based on its wavelength or frequency. This include radio waves, microwaves, infrared radiation, visible light, ultraviolet radiation, X-rays and gamma rays. These properties of electromagnetic radiation are important in understanding how it interacts with matter and how it is used in various applications such as communication, imaging and energy production. Molecular analysis using UV or visible spectroscopy. UV or visible spectroscopy is a widely used technique for molecular analysis in chemistry, biochemistry, and other related fields. It involves the measurement of an absorption or transmission of light by a sample in the ultraviolet and visible regions of the electromagnetic spectrum. The spectroscopic data obtained from this analysis can provide valuable information about the electronic structure and properties of the molecule in the sample. Here are the basic steps involved in molecular analysis using UV or visible spectroscopy. Sample preparation. The sample is prepared by dissolving or suspending it in a suitable solvent that does not interfere with the analysis. First, sample is prepared by dissolving or suspending it in a suitable solvent that does not interfere with the analysis. The sample must also be transparent to UV or visible light. Then instrumentation. The UV or visible spectrophotometer is used to measure the absorption or transmission of light by the sample. This instrument consists of a light source, monochromator, sample holder and detector. The sample is placed in the sample holder and a beam of UV or visible light is passed through it. The monochromator is used to select the desired wavelength range, and the detector measures the amount of light that is absorbed or transmitted by the sample. Then data analysis. The data obtained from the spectrophotometer is analyzed to determine the absorption or transmission spectrum of the sample. This information can be used to identify and quantify the molecules in the sample as well as to determine their electronic properties. So, which are the applications of UV or visible spectroscopy? Include the analysis of DNA and RNA in biochemistry, the measurement of protein concentrations, and the analysis of environmental samples for pollutants. It is also used in the pharmaceutical industry for drug development and quality control, as well as in the food and beverage industries for quality control and safety testing. Next is the mass spectroscopy principle, working parts, applications, and types along with its importance. Mass spectrometry is a powerful analytical technique that is used to identify and quantify molecules based on their mass to charge ratio. This technique involves the ionization of molecules, separation of ions based on their mass to charge ratio, and detection of the separated ions. Here is an overview of the principle, working parts, application types, and importance of mass spectrometry. Principle. The principle of mass spectrometry is based on the ionization of molecules and separation of ions based on their mass to charge ratio. The ionization of molecules is achieved by bombarding them with high energy electrons, causing them to lose one or more electrons and become positively charged ions. These ions are then separated based on their mass to charge ratio using an electric or magnetic field. The separated ions are detected and their abundance is recorded to generate a mass spectrum, which provides information about the molecular weight and chemical structure of the molecules in the sample. In mass spectrometry, the sample is ionized by an ion source, which can be a gas phase ionization method or a surface ionization method by bombarding with a suitable material, and the ions produced are then separated. Bombarding them with high energy electrons, and the ions produced are then separated based on their mass to charge ratio using a mass analyzer, which can be a magnetic sector, a quadrupole, a time of flight, or an ion trap analyzer. Which are the analyzers? Magnetic sector, quadrupole, a time of flight, or an ion trap analyzer. The separated ions are detected by a detector, which generates a signal that is proportional to the number of ions hitting it. The signal is then processed by a computer to generate mass spectrum. The main parts of mass spectrometer include the ion source, a mass analyzer, a detector, and a computer system for data acquisition and analysis. So, mass spectrometry is widely used in many fields, including chemistry, biology, medicine, and forensics. It is used for structural elucidation of molecules, identification of unknown compounds, determination of molecular weight, analysis of isotopic composition, and acquisition of trace amounts of substances. It is also used in the proteomics and metabolomics of identifying and quantifying proteins and metabolites. Next, there are several types of mass spectrometers, including magnetic sector, quadrupole, time of flight, and the ion trap mass spectrometers. Each type has its own advantages and limitations and is chosen based on the specific application. Next, mass spectrometry is a powerful analytical technique that is widely used in many fields for identifying and quantifying molecules. It has revolutionized the fields of proteomics and metabolomics by enabling the identification and quantification of proteins and metabolites, respectively. It is also used in drug development, environmental analysis, and forensics, among others.